In L3 plus auto-driving systems, mmWave 4D imaging radar plays a rather important role, targeting 4D premium radar and imaging radar applications. Calterah has launched the next-generation mmWave radar SoC platform of Andes, adopting the 22nm node process. Andes 44R SoCs offer gigabit Ethernet interfaces and have met the requirements of SOB compliance and AEC-Q 100 Grade 1. Regarding computation power, flexible architecture, debugging functions, and cybersecurity, the products are obviously leading the market. Firstly, among ICs of its likes, Andes has the strongest computation power, enabling higher speed signal and data processing and more advanced algorithms. The 4 CPU cores of Andes at work altogether provide 2,680 DMIPS, and Andes DSP can process data at a rate 3 times, even 10 times of that in products of our competitors. A proprietary RSB is integrated in Andes as well. What's more, Andes SRAM can extend to as much as 4.8 MB through memory sharing and OTP, supporting XIP and parallel processing of data read and write. Secondly, the flexible architecture makes Andes fit for requirements of different waveforms in all use scenarios. The RF subsystem has a 7-bit phase rotator for greater resolution and accuracy. The rotator is based on a transmission line and its control is linear, which greatly simplifies its use. The RF subsystem supports flexible waveform generation. The subsystem also integrates an accurate digital compensation module and implements an optimized floor plan for better channel isolation, which is conducive to the realization of cascading. For SoC-level cascading, Andes provides a C2C interface for data exchange. Different numbers of Andes SoCs can be cascaded for systems of various scales as needed, known as flexible cascading. The upper protocol of the C2C interface is based on AXI. This means the chips in the cascading system can share one code base, greatly shortening development time. Also, distributed signal processing is supported in cascading, delivering a significant efficiency increase. Thirdly, Andes provides a convenient debugging system among ICs of the same specs. The complicated development of imaging radar calls for convenient debugging functions. Andes SoCs offer effective debugging interfaces, channels, and analytic modules. The interfaces include JTAG, high-speed Aurora, and SPI debugger. Last but not least, in response to the ever-growing demand for automotive cybersecurity, Andes has a hardware security module, meeting the requirements of the main control chip of a vehicle. It has a safety island design and only the CPU within HSM can access resources. External processors in the chip need to use mailbox to communicate with the CPU. In the HSM, there are also crypto hardware accelerators, supporting common encryption and decryption algorithms. And this currently consists of 2 part numbers, CAL77C644 and CAL77C844. The only difference is the latter supports flexible cascading. Samples of the 2 Andes products will be available in the second quarter of 2023, hopefully helping ushering a time when 4D mmWave radar of all kinds comes to mass production.